Okay guys, so this is percentage yield. First thing I advise you do is pause the video and just copy this down into a flashcard so you've had a chance to read through it before I apply it to the question. So if you want to pause the video now and do that. Welcome back. So here's how we'd apply this method to a question. So let's say we've got an equation and we're told we started with 14 grams of ethene, 10 grams of hydrogen gas, and after we did the experiment we ended up with 1.2 grams of ethane. So step one, we're going to find the moles of our limiting reagent. Now the limiting reagent is the reagent that you run out of first. So if everything's got a 1-to-1 molar ratio, it's going to be the reagent you have the least moles of. So let's figure out that then, which is the limiting reagent, and incidentally the other chemical we would say is in excess. But we don't care about that, all we care about is the limiting reagent. So first of all, let's find our moles of ethene. So moles equals mass over mR. So 14 over 28, that's going to be 0.5. Find our moles of hydrogen. So that's 10 over 2, which is 5. Now, as it's a 1-to-1 ratio, for every mole of this we use up, we're going to use up 1 mole of that. So we can see from these numbers, clearly we're going to run out of ethene first, so this is our limiting reagent. If these weren't a 1-to-1 ratio, if there was a 2 somewhere, we're going to have to take that into account as well. So just be aware of that. There is a slightly harder version of this question. Either which way, we know that. Don't care about the hydrogen now. Step 2, and this is the step everyone tends to forget. So you should put a little star next to that to remind yourself, do remember to do this step. So what we're trying to figure out is what mass of product should we expect to get if everything went perfectly. Now, if we started with 0.5 moles of this, and it is a 1-to-1 ratio, we should expect to get 0.5 moles of product. And that's what that step there is. So step 2 is a 1-to-1 ratio. So our maximum possible moles of product, if everything went perfectly, should be 0.5 times 1, which is 0.5. Just to go through a slightly different question, this won't balance now, but let's pretend there was a 2 there. Now, for every 1 mole of this, we should expect 2 moles of products. So if my moles of ethene was 0.5, my maximum possible moles would be 0.5 times 2, because for every one of these, you end up with 2 of them. So you'd have a maximum possible moles of 1. However, there isn't a 2 there, it's a 1-to-1 ratio, so that's our maximum possible moles. Next, step 3, we want to figure out how many moles of product did you actually end up with. So we're going to again just do moles equals mass over mR. So that'll be 1.2 over 30, which comes to 0.04. Now, your actual moles of product should always be equal to or less than the maximum possible moles. How can you end up with more product than the maximum possible, right? So if this, as a little safety net, if this does end up being more than the maximum possible, you've gone wrong somewhere. So go back and just have a little think about something. So we've got our maximum possible and our actual moles. All we need to finally do is bang it in the equation, percentage yield equals actual over maximum possible times 100. So just do it here. So percentage yield is the actual over maximum possible times 100 to get it as a percentage, and that should come out as 8.00%. Okay. I'll just go through one more practice question. For this next one, I'll write the question up and then pause the video, have a go at it yourself, and then you can use the rest of the video to go through your answer and mark it yourself. Give me 2 seconds to get this written up. Okay, so pause the video now, have a little crack. This is the desired product. Let's say we're trying to make some hydrogen gas, so we can kind of ignore this a little bit. Try and figure out what the percentage yield is. Welcome back again. So what we're going to do here, step 1, find the moles of limiting reagent. Now, there's only one reagent, so that must be the limiting. So moles of C3H8, again, mass over MR. Sometimes you might need to use volume of a gas divided by 24, or volume times concentration. So just read the question. And so that's going to be 85 over 44. Like so, and I've rounded a little bit there to not make the board too messy. We are then going to compare our moles of limiting reagent to our molar ratio of the useful product. Now, it is a 1:2 ratio. So for every 1 mole of this we start with, we should expect to get 2 moles of product. So my maximum possible moles is my moles of limiting reagent times by 2, because of that molar ratio. And again, that's the bit everybody always forgets, so do remember to check that. So my maximum possible moles will be so. Now let's figure out how much did we actually end up with, my actual moles. So moles of H2, mass over MR, 0.2 over 2, which is, I really shouldn't need to use a calculator for this, 0.1. Again, bang it in the equation, so the percentage is your actual 0.1 over your maximum possible, which should always be the bigger number, times by 100 to get it as a percentage, and we'll end up with 2.59%.